everyone. Today we are going to continue learning about the different types of probabilities, but we are going to compare them. So our essential question today is, how do we compare theoretical versus experimental probability? So we're going to use both. We're going to solve a problem using both types, and then we're going to compare the odds of the numbers. So let's start with our very first example. And in our first example, we have a bar graph that looks like this. So I'm just going to scooch this up. Hopefully that's not covering my face. Hopefully my face is in front of this. But we're going to look at this, and we are going to compare the theoretical and the experimental probabilities. That is what we're going to compare. So let's get this over out of the way just a little bit more. Okay, so we have the number that's rolled, we have the times rolled, and we know that the title is rolling a number cube. So we're rolling a number cube. We're going to have the numbers rolled and the times rolled. So in our first thing, it says, how does the experimental probability of rolling an odd number compare to the theoretical probability? So we want to roll an odd number. So we're looking at rolling an odd number. So example number 1. Okay, so the first thing we want to do is let's figure out the experimental probability. So experimental probability. And we know the experimental probability is going to look at the probability of rolling an odd number. And in order to do that, we are going to create a fraction. And in our fraction, we're going to have the number of times the event happens over the number of trials. So the number of times the event happens over the trials. So an odd number. Well, 1 is odd, so that's 48. And 3 is odd, so that's 50. And we also have 5, which is 49. So this is how many total times an odd number has come up. So this is how many times an odd number has come up. We're going to add that up, and we get a total of 147. So we could have rolled an odd number 147 times. On the bottom, it's the total number of rolls. Well, the total number of rolls that happened would be adding up 48, 53, 50, 52, 49, and 48. So 48 plus 53 plus 50 plus 52 plus 49 plus 48, and that equals a total of 300. So 300, 147 out of 300. That is the total number in our experiment. So now we need to reduce this down and find the total percentage. So we're going to get this to be out of 100. So we want 147 over 300 to equal something out of 100. Well, we know that to get from 300 to 100, we divide by 3. So we need to divide by 3 on the top. 147 divided by 3. So if we do 147 divided by 3, that's going to give us 49%. So experimental probability has a 49% chance of rolling an odd number. So let's look at theoretical probability. So if we were to find the theoretical probability, so let's look at the theoretical probability, I'm just going to call it TP, like not toilet paper, but theoretical probability. Theoretical probability is the event or the likelihood, the number of favorable outcomes. So how many odd numbers are there? So again, we're still rolling an odd, but the difference here is how many odd numbers are available to roll. Well, there's 1, 3, and 5. So we have 3 chances here of rolling, 3 chances of rolling an odd number out of 6 total chances. Okay, there's 6 total numbers. So we have 3 out of 6 numbers that we could roll. So 3 out of 6 are odd. Well, 3 out of 6 is the same thing as 1/2 or 50%. So we had a 50% chance. So the theoretical probability is very close to the experimental probability. So 49% is close to 50%. So that is the comparison, 49 to 50%. Very, very close in odds. Okay, we're going to do another example. And let me see if I'm going to use the same idea or if I want to use a different example. Okay, our next example that we're going to look at is about a spinner. Okay, so we're going to have a spinner and we spin it 100 times. So here's our spinner. And the spinner can be spun 100 times. And in that 100 times, we can spin a 5, a 1, a 2, a 3, or a 4. Okay, and we want to know what's the likelihood of spinning a 5. Well, after 100 spins, the number landed on versus, so you could land on a 1, a 2, a 3, 4, a 5, or a 6. And the number that it was landed on, the frequency that we landed on these numbers was 17, 19, 21, 18, 25. I messed up. I was doing a number cube. Ignore that end. Okay, so we're going to compare probabilities. So we're going to compare the theoretical with the experimental. So we're going to compare. So first of all, let's take a look at the experimental probability. So experimental probability, remember, is what we actually spin. So we spun, the probability of spinning a 5, we had 25 spins. 25 out of 100 total spins. So 25 spins that landed on 5 out of 100 because there's the frequency, right? If we add all these up, we get to equal 100. Spinning a 5, 25 out of 100. Well, 25 out of 100, it's already out of 100, so we have a 25% chance of spinning a 5. 25% chance. Now, theoretical probability, the theoretical probability is spinning a 5 out of the total possible outcomes. So there's only one 5 out of the 5 total outcomes. So there's one 5 out of the total. Up here we had 25 spins. 25 spins landed, right, out of 100 spins. Let's do 25 landed. 25 landed spins out of 100 total spins. Here, you could only pick one 5 out of the outcomes. So 1 and 5. Now we're going to do 1 and 5. We want to divide this. 1 divided by 5. So we want 1 divided by 5. And this is going to give us a total of 1 divided by 5 gives us 0.2. But we know it's 0.12, right? So we have to go 20%. So look, the difference here is quite big by 5%. There's a 5% difference in the probability, or 5% difference in spinning one or the other. So 25% difference. Okay, it is your turn now to do a try it. And I think on this try it, it's going to have you use the original chart. So we're going to use that original chart again. And your try it says, how does the experimental probability of rolling a number greater than 1 compare to the theoretical probability? So we're going to be looking at rolling a number greater than 1. Okay, so rolling a number greater than 1. We're going to use this image again. And so you're going to compare the theoretical probability and the experimental probability. So go ahead and hit pause right now so you don't hear me talking. And then when you are ready, come on back and hit play. All right, so let's do the experiment first. If we do this experiment, the experimental probability, we are going to roll a number that is greater than 1. So in our experiment, we rolled a 53. We rolled a 50. We rolled a 52 times. We rolled a 4. We rolled 49 5s. And we rolled 48 6s. Okay, so this many. So we had 53 2s, 53s, and so on, all the way up. So these are all greater than 1. And this is out of a total of 300 still. So when we add all this up, where's my calculator? I had too many tabs open. Okay, so when we add this up, we have 53 plus 50 plus 52 plus 49 plus 48. This gives us a total of 252 over 300. So we had 252 rolls that were out over 300. I mean over 1, out of 1. So now our job is to divide by 3 because, again, we're trying to get to 100. So divide by 3 and divide by 3. So 252 divided by 3 gives us 84. And this equals 84%. So 84% of our rolls were greater than the number 1. Okay, that's the experimental probability. Now we're going to look at the theoretical probability. So the theoretical probability says how many times could we have rolled a number greater than 1? Well, 2, 3, 4, 5, and 6. So there are 5 numbers greater than 1 out of 6 total. So 5 divided by 6, 5 divided by 6 is a total of 83%. Look at that. They are so close. The probabilities are very, very close. So as the number of trials increases, the experimental probability gets closer to the theoretical probability. So how do we compare them? It says that as the number of trials increases, so as we do more trials, the more trials we do, the closer the experimental probability and theoretical probability get. Okay, go ahead and write your level of understanding out to the side. Where are you at now at comparing these two? When you are ready, you can come on back to the Google Meet and ask for help, or you can go on and do your practice work. As always, I appreciate all of your hard work and effort, and make it a great day.